Hi, today we're going to be talking about this theorem, in which we have a Poisson process with parameter k. W is the time of the occurrence of the first event. W has an exponential distribution with mean 1 over k. So here I want to clarify a few things. There are two distributions involved. The first is a Poisson process, which is discrete. The second is a continuous random variable, W, which is the time until the first event, which often denotes failure in the example below. We're told how to calculate probabilities with W, and that's with an exponential distribution. And the exponential distribution has a parameter, beta, that represents the mean. We're told the relationship between W and the parameter of the Poisson distribution. Let's talk about this example. We have an electronic component which fails once every 6 months. We're asked to calculate the probability time, a continuous random variable, until the first failure of the electronic component is 9 months or more. So we are going to use this theorem to calculate the probability, and we'll just note the number of failures. That is discrete, and that is a Poisson distribution. We know from this problem that the parameter of the Poisson distribution is 1/6, one failure every 6 months on average. So the parameter beta is 1 over k, which is 1 over 1/6, or 6. We're told how to calculate probability W is bigger than 9, and that is with the exponential distribution that is in the box. If I want to calculate the probability W is bigger than 9, I'm going to do the complement rule just to make my life a little bit easier and to not have to deal with an improper integral. So the probability is calculated with a Poisson distribution. I integrate from 0 to 9 of 6, 1/6 times e to the minus w over 6 dw. Now, when we integrate this, I will leave the constant alone. I'll integrate e to the minus w over 6, and you can use a u substitution if you'd like, or you can see that you'll just get that. Okay. Now we evaluate at 0 and 9. The 1/6 cancel, and so do the negative signs. So I'll get 1 plus e to the minus 9/6 minus e to the 0, which is e to the minus 9/6. Okay. Now all we have to do is calculate that number and get that this is approximately 22% chance that it fails within, that it fails after 9 months. So the chances are that it will fail within 9 months rather than after 9 months. But I want to just highlight this theorem and its uses. So we use this theorem to calculate this probability. Thank you very much.